Bueller, 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 Bueller. Well, apparently he's sick, so we're going to go ahead and move on with this lesson anyway. Welcome to assignment 3-1. Now that you've completed assignments 1 and 2 in the book, you're ready to get on to some more advanced stuff. The big new innovation in this assignment is going to be the use of 2 maps at once, which sounds a little bit intimidating at first, but it's really not too bad. You'll see. What we're going to do in this is we're going to make 2 different maps of Orange County, California, and compare the 2 side by side. This is the checklist that we're going to use for the assignment. We're going to be looking for 6 different things. We're going to have 1 map that shows the population that's age 5 to 17, 1 map that's age 65 and higher. We're going to have some color gradations that make sense for the 2 that fit the data. We're going to have the same numerical scale for both. We're going to have a graphic bar scale in miles that shows the scale of the maps. We're going to have a title, and we're going to have a legend. And I guess that's actually 7, not 6. All right, so luckily counting is not part of this assignment. All right, back to GIS here. First thing that the assignment asks us to do is to add data from the CA Orange County Tracts shapefile. So we just go and left click on the Add Data button. Remember that when it asks you to add data, you're not going to go in and go to File, Open. You're not opening a new map. You're adding data to your current map. And remember that if you can't get into the file here, it's probably because you haven't connected the folder yet. I still don't understand why you have to connect the folder, but you just do. All right. So I'm already in this United States.gdb. This is in the data, and then it's under United States.gdb, and here we are as CA Orange County Tracts. So just double click that, and that'll add us in there. Kind of ironic that it's Orange County, and yet it looks purple on our screen, huh? All right. Now we show how it looks based on the population. So if we open this attribute table, just right click here and click on Open Attribute Table. We can see that we have all sorts of data that's already in the shapefile. We can see that among these data are population. So it has for every census tract the number of kids who are aged 5 to 17, 18 to 21, etc., all the way up to age 65 and up. So what we want to do is we want to compare this number to this number, but not just the raw numbers. We want to compare them as a percentage of the total population, which is over here, population 2000. We're going to use in the year 2000. I guess the assignment's a little bit out of date since they have a newer population here, but that's what the book asks us to do, so that's what we're going to do in this case. All right, how would we go about doing that? We want to shade in each tract a different color depending on what percentage of the population is between ages 5 and 17. What do you think the first step would be? First thing you should do is you should open the properties. You got one of 2 ways. Either you can right click on the layer and go down to properties, or the easier way is to just go and double click on the layer and it opens up properties. And remember symbology here, this is where you change how it's displayed. If we go down to quantities and we do graduated colors, that'll have different colors that change. All right, you should remember that from the last couple assignments you had to do just the value changing here. So the value we want is age 5 to 17. That's the number of kids in each census tract that are between ages 5 and 17. But we don't just want the number, we want the percentage of the total population. What this does, the value over the normalization, this becomes the numerator and the denominator. We want to put the population 2000 down here in the denominator, and now this is going to divide age 5 to 17 by population 2000. So I'm going to undo this and watch again the range here. This is just a count, 0 to 474, etc. Now when I go and plug in this population 2000, now this becomes a fraction here. Age, the total number of kids divided by the total number of people. And you can see this is up to 0.33, so basically up to 33% of the population, school-age kids. So we could hit OK. Is that shading okay? Maybe you want to go back, select a different color. That's up to you. I'll leave it on the blue for now. The other thing we want to do is we want to make these breaks in the numbers make sense. And we have to do a little bit of forward thinking here. These breaks might be okay for these data, but when we compare them to 5 population, or 55 over, I should say, they might not be okay. So we don't want the highest number here to be 0.33. We want it to be 1. So just click on there, type in a new number. You could also wait until we make the separate age 65 map to do that. That might actually be a better way of doing this. I've already made it. I'm going to go in and put in some numbers that I think will work pretty well. I'm just going to do 0.4, 0.3, 0.2, and 0.1. These don't have to be the numbers that you use. So you'll see that there's not really any need to have a category that's 0.4 to 1 on here when the highest number is 0.3. So that's foreshadowing a little bit what's going to happen with the age 65 and over data. Hit OK. Okay, again. Okay. You'll notice that none of them are shaded this really dark blue. And that's for the reason I just showed you. Now, the next thing that we have to do, this is what you haven't done before. The normalization and this are the two things that are really the only two things you haven't done before. We need to get, well, actually, before we even do that, let's change, no, you know what, let's not do that yet. Okay, now we need to get this map again, but for age 65 and over. There are multiple ways that we could do that. The easiest way to do it, I think, is to just copy and paste what we've already done. And that's why I went ahead and I did all the shading and everything before I made a second data frame. So all you have to do is, if you right click on the layers here, this is a data frame. And you do copy, and then notice if you try and right click on layers again, you can't do paste. And if you try and right click anywhere else on the map, or in the table of contents rather, let's say try and right click here, there's no paste. So what you have to do is go up to edit here, and now you do paste, and now this is a separate data frame. And you can rename these data frames just the same way that you rename the layers. Name this one, kids, and this one seniors, or whatever you want. All you have to do to change it is click on it once, and then click on it again. So click once to highlight, and then click once again to bring the cursor up. Notice that's not double clicking, it's click once, stop, and then click again. Now we have, this is still age 5 to 17 over here, and we want this to be age 65 and over. All we have to do is go back in here and do pretty much the same thing we already did, except that we're going to choose age 65 and up. Now you notice that, annoyingly, it changed these back to the natural breaks when we did this. So we'll have to go back in here and fix this again. And now you see the distribution of these data, why we need the categories that are higher numbers. We have one that's 0.44, one that's 0.89 in these data. So a couple of tracks that are a lot higher numbers. So again, we want the highest one to be 1. So I'm going to do the 0.4, 0.3, 0.2, 0.1. You can make an argument that's not really the best way to do it, because now this 0.44 and the 0.89 are those are all in the same one together. We actually have, you see that we have 1, 2, 3, 4, 5, 6, 7, 8 of them that are above 0.4. Maybe you want to differentiate between those two. Maybe you're on your map, you think that we show the difference between something that's 80% and something that's 45%. That's up to you. The important thing, though, is that the two maps need to have the same scale, because we're comparing the two maps against each other. All right. So you notice these have the same scale. Let's not worry about these zeros for now. Now, you notice this is showing the age 65 and higher. And you only see one map. So if you go back and click on this, it doesn't change the map. What you have to do is you have to right-click on the data frame, go down to Activate, and now you see it switches the map. The next thing we have to do is get ready to print this. We want to see both of them. Even when we activate one layer, we can't see the other one. All we have to do for that is go to View and choose Layout View. Now, you'll notice that mine here, this is in landscape position. So if we right-click on this, go to Page and Print Setup, put it on Portrait Layout. All right, and now it looks like we only have one map, but if you click here and you drag this, you see that we actually have two maps. They're both one on top of each other. So you can resize the maps here. There are various ways you can try and get them the same size. You do want them the same size because we want them to be zoomed in on the same level here, so that our scale will be applicable to both of them. So one way you could make them the same size is you could put one on top of the other, and you could just try and match the dimensions. You can probably either get it or get really close to it by doing that. The other way you can do it is to put these guidelines in. So you see this one's already right here. That's from a previous map that I was doing. So you can click on this and drag it away. So all you have to do is click on the map here, or click on the bar up here. Put one at 1/2 inch. So we can pull one. Let's leave room for the title. So put one 9 inches to 5 inches. That would be a 4-inch map. Well, here, let's leave an inch for the title. So let's go 9.5 to 5.5 would be 4 inches. And then 5 to 1 would be 4 inches. And then we can have this one be 1/2 inch to, let's just say 6 inches. Why not? All right. So the first thing you notice is when you click on this and drag it in, it'll snap to those lines. And then when you try and make it larger, it'll snap to those lines. So you have to see, even when I move it around, it doesn't go past those lines. I mean, I could keep dragging it, it would eventually, but now we can make the other one the same thing. Drag it down to here. All right, and now the way that we can confirm that these are exactly the same size is if we click in one and we hit full extent. There you go, 1 to 677,412. So in this one, do the same thing. Oh no, they're not quite the same. Well, it looks like I messed that one up somehow. I don't know what I did. Interesting. Never had that happen before. Well, I don't know why I can't get them to quite line up here, but we can just manually edit this. So 673, 865. Just click in here, 673, 75. 5. Oh, 865. All right, so now they're both zoomed in the exact same amount. All right, now we need to insert legends for both. What we want to do here is insert legend. This will take you through a whole menu. We don't need to worry about this right now. We'll worry about this in another assignment, though. That'll give you your legend right there. Enough room. And so now, actually, that's this one. You see that it was the activated layer, or activated data frame rather. So now we need to activate this data frame, insert legend. Got those lines right there. I messed this up before. All right, the other thing you could fix is make these numbers all have the same number of zeros before and after the decimal place. I'm not going to worry about those for right now. The other thing we need to do is insert a scale. So now that we have both of these are zoomed into the exact same ratio, so we can just do insert scale bar rather, go into properties, and division units, we want to do miles. And you can choose the one that you think makes most sense. Okay, and then now we can choose this. Okay. And we want to put this down at the very bottom here. Right now it goes up to 28 miles, so maybe we want to shrink this down a little bit so it goes to 20 miles. That would be good. Okay, and that gives us an idea of how big Orange County is here on this map. Okay, did we get everything? Oh, title. You got to put a title in. So all you have to do is insert title. Orange County. Oops. Orange County. There we go. And then I'll go to the top. No offense to anyone over the age of 65 who's watching this. You can come up with a little bit more official sounding title for yours. Okay, is that everything? Here we are back at the checklist. The item number 1, map of percentage who are age 5 to 17. Yep, we have that. So check. Map of age 65 and older. Check, we have that. Sensible color gradations. I think these are sensible. We can see that we can see the difference between the different colors, and they fit the data. The ones in the highest categories we can see are showing up. Wow, you know what I realized we just did here? This automatically went to the right place the first time. That's at 65 is on top. I didn't even notice that. All right, so the age 65 population throughout the county, we noticed there are fewer people age 65 and older, but in these very few census tracts here, we have very, very high populations of people over the age of 65. Okay, sensible color gradation, so check. Same numerical scale for both, so 0, 0.1, 0.1, 0.2, etc., 0.4 to 1, so those are all the same. Graphic bar scale in miles, so here we go, bar scale miles. Readable title, it is. And a readable legend, this should say legends. And check. All right, I got 100% on that assignment. Hopefully you did too.